Now we're going to move down to homework problem number 10. And we're going to look at operations with radicals in them. And so really, when we're adding or subtracting, radicals behave like variables. So if you're ever wondering if you could add or subtract something, just think about if they were variables. So for example, if I had 2x plus 3x, I could write 5x. That's exactly the same if I have 2 square roots of 7 plus 3 square roots of 7 would be 5 square roots of 7. Notice the radical didn't change. But if I had 2x plus 3y, you can't add those. You cannot combine them. In the same way, I would have 2 square roots of 7 plus 3 square roots of 5. I can't combine those under addition or subtraction. So just a couple of ways to think about combining those. So the other thing, first step, is always reduce your radicals first. Your radicals must always be presented in lowest terms, just like fractions. You would not leave 4/6 as an answer. You would write that as 2/3. Just like you're not going to leave the square root of 8, you will always reduce that to the square root of 2/2. Not magic, that is how that reduces. So let's look at these. The square root of 27 can be reduced. The square root of 2 can't. So off to the side, I'm going to factor 27. And that is 3 times 9 and 3 times 3. So 27 is 3 squared times 3. So that means this one's going to come out 3 square roots of 3. That's how that reduces. So this is going to become -2 times 3 square roots of 3. So you see how I replaced my square root of 27 with 3 square roots of 3. Plus 3, and then I've got another one that I'm going to basically substitute, 3 square roots of 3. And I'll erase my little example there. And then this one stays the same, minus 2 square roots of 2. So I'm going to multiply these together. -6 square roots of 3 plus 9 square roots of 3 minus 2 square roots of 2. So the only ones that combine are the ones that have exactly the same radical. So they combine just like if they were variables. So -6 plus 9, I'm going to have 3 square roots of 3 minus 2 square roots of 2, and that won't combine. So this is your answer. If we jump down to the next section and we take a look at number 15, multiplying and dividing, the rules are a little different. So much like variables, if you have 3x times 2y, you can combine this as 6xy. So we can go ahead and put things together just like we can with variables. So I could multiply 15 times 5 and get 75 and factor 75. But what might be easier is if we write it as a single radical. 15 is 5 times 3. And so I have 5 times 3 times 5. So I took that 5 and both of those numbers. And then I have v times v times v cubed, or v squared, sorry. So these two are my v cubed and then my leftover one. Why would I expand it all out like that? Because now it's like the very first section. These two 5s are 5 squared. So those are going to come out front. This 3 doesn't have a perfect square, so it stays under. These two v's go together as a v squared, which will come out. This v squared comes out, and I have 5v squared square root 3 as my final answer. Had you multiplied it to 75, v to the fourth under the radical, if you multiplied both of these together, you would get the same answer because you're going to have 25 times 3, and you're going to have 5 times 5, and then this will split into v squared and v squared. It's just if we can avoid working with those bigger numbers to multiply to have to factor and just go ahead and factor the two smaller numbers, it goes a little bit quicker. If you glance down in your homework to, for example, number 20, I just want to quickly go through. Don't be alarmed with this root in the bottom. Just go ahead and simplify your roots like normal. The square root of 9 is 3. 8 is 4 times 2. The square root of 4 is 2. So I'm going to have 2 square roots of 2. This 2 gets left over. Square root of 9 is 3, so the radical is gone, and I have 4 times 3 in the bottom. And then, as always, we need to reduce our fractions. 2 and 4 have a common factor of 2, and so I'm left with the square root of 2 over 6. So just always reduce your fractions first. Those are your examples for section 1. Good luck!